The process of evolution. Charles Darwin was a British naturalist who proposed the theory of biological evolution by natural selection. Darwin defined evolution as descent with modification, the idea that species change over time, give rise to new species, and share a common ancestor. The mechanism that Darwin proposed for evolution is natural selection. Because resources are limited in nature, organisms with heritable traits that favor survival and reproduction will tend to leave more offspring than their peers, causing the traits to increase in frequency over generation. Natural selection causes populations to become adapted, or increasingly well-suited, to their environments over time. Natural selection depends on the environment and requires existing heritable variation in a group. Georges Louis Leclerc, September 7, 1707, April 16, 1788, a naturalist, noted that although different places have the same environment, they also had similar but unique wildlife. He hypothesized that those species changed as time passed. This belief became the first principle of biogeography, which focused on the distribution of species and ecosystem in a geographic or through geological time. Jean-Baptiste Lamarck. The second part of Lamarck's mechanism for evolution involved the inheritance of acquired traits. He believed that traits changed or acquired over an individual's lifetime could be passed down to its offspring. Sir Charles Lyell, Baronet, Scottish geologist largely responsible for the general acceptance of the view that all features of the Earth's surface are produced by physical, chemical, and biological processes through long periods of geological time. The concept was called uniformitarianism, initially set forth by James Hutton. Lyell's achievements laid the foundations for evolutionary biology as well as for an understanding of the Earth's development. He was knighted in 1848 and made a baronet in 1864. Evidence of evolution. Scientists who study evolution may want to know whether two present-day species are closely related. Evidence for evolution can be structural, genetic, or biogeographical. Structural evidence for evolution. Observing anatomical features shared between organisms, including ones that are visible only during development, can indicate that they share a common ancestor. Structural evidence can be compared between extant, currently living, organisms and the fossils of extinct organisms. Homologous structures. If two or more species share a unique physical trait, they may all have inherited this trait from a common ancestor. Traits that are shared due to common ancestry are homologous structures.